All right, take a look at number 38. 38 says, what is the sine of negative 270 plus the cosine of 450? Well, I don't like either of those angles. What is a different way to write negative 270? 90. So I could take negative 270, add 360 to it, and I get 90. And I also don't like 450. What am I going to do with that? Subtract 360, and I get 90. Well, what is the sine of 90 degrees? So right here, what are the coordinates at that point? 0, 1. And the cosine of theta is equal to x, and the sine of theta is equal to y. How do I remember that? Alphabetical order. Cosine and sine in alphabetical order, x, y in alphabetical order. So the the sine of 90 degrees is 1. Plus the cosine of 0 degrees is 0. So the answer is just 1. All right, look at, let me go back. Look at number 40. The cosine of negative 720 plus the tangent of 720. What angle is coterminal with 720? 0. You can just add 360 until you get back to 0. So this is like saying, what is the cosine of 0 plus the, that's a 0, plus the tangent of 0? Well, right. So at 0 degrees, I have 1 comma 0. Cosine is going to be the x value, 1, plus, how do you do tangent? Well, tangent is equivalent to sine over cosine, which translates into y over x. So it's 1 plus 0 over 1, which is 1. Does everybody understand this? So how did I get cosine what? So I found a coterminal angle to negative 720. Negative 720 is 2 reverse loops. So I just changed it down to 0. So on your unit circle, cosine of theta is the x value, and sine of theta is the y value, and tangent is y over x, which is sine over cosine. So if I had the sine of 540 minus the cosine of 1060, what is that going to be? Well, 540 minus 360 is 180. So the sine of 180 minus 1060, I'm going to subtract 360. It's still too big. Oops, I meant 1080, sorry. So 1080 subtract, I meant 1080. Subtract 360, still too big. Minus 360, still too big. Subtract 360, and I end up with 0. So what I'm really asking is, what is the sine of 180 minus the cosine of 0? So we go to the unit circle. This is 1 comma 0, and this one is negative 1 comma 0. the sine of 180 is the y value at 180, which is 0, minus the cosine of 0 is 1. The 0 is positive 1. We'll do a radian one in just a second. Okay. What about the cosecant of 810 minus the cotangent of let's do 630. There's cotangent of negative 630. First off, let's change the angles. So 810, I'm going to keep subtracting 360 until I get an angle that's, I know where it is, 90. So this is the cosecant of 90 minus negative 630. I need to convert that into the smallest possible positive angle. So I just continue to add 360, and it's also 90. Okay. Now, I don't know cosecant and cotangent. So what should I do? Well, I'm going to find the reciprocal and then just flip the answer upside down. So I'm going to find the sine of 90 minus the tangent of 90. And then once I get my answers, I'm just going to flip them upside down. Does that make sense? So at 90 degrees, what is this point? 0, 1. So the sine of 90 is 1 minus, what is the tangent of 90? Y over x, which is 1 divided by 0, which is infinity. You can't divide by 0. So this one doesn't have an answer. Now, let's change this. What if it was the cotangent of 180? Well, at 180, I have negative 1 comma 0. Tangent would be 0 divided by negative 1. 1 minus that is just 1, but is that my answer? I need to flip that upside down, which is ends up still being 1. Well, this is always 0 degrees, so that would always be 180. All right. What about the cosine of 7 pi over 2 minus the tangent of 6 pi? So this one's in radians. If I have 7 pi over 2, how do I convert that into a radian measure that is the smallest possible positive measure? No. How do I know 7 pi over 2 is not on the unit circle? No. What is it about this that tells me it's too big? It's bigger than 2, also known as 4 over 2, right? So I just need to subtract 4 over 2. So I get the cosine of 3 pi over 2. Minus, what about the tangent of 6 pi? What's that equal to? What angle on the unit circle is equal to 6 pi? Nope. Where is 6 pi? It's 0 radians. Right? We have the unit circle, 2, 4, 6. That would be it. So what we're really finding is the cosine of 3 pi over 2 minus the tangent of 0. Okay. Well, on the unit circle, this is 3 pi over 2, which is 0 comma negative 1. And then tangent is 1 comma 0. What is the cosine of 3 pi over 2? 0. Minus, what is the tangent of 0? 0 over 1. So the answer is just 0. Okay. All right, the next set is really simple. It just says, does the following angle exist or not? So the sine of theta equals 0.45. Does that exist or not? The answer in this case is yes. How do we know? Well, what if I change it to say that? Can the sine of theta equal 1.45? Well, the sine of theta is equal to opposite over hypotenuse. What is wrong with this? It's bigger than 1. Can the sine of an angle equal 1.45 divided by 1? The answer is no. Why not? Look at that triangle right there. Why can the sine of theta not be 1.45 over 1? Exactly. So this opposite piece has to be smaller or equal to the hypotenuse. Can they actually be equal? And the answer is yes, at 90 degrees. Right? If at 90 degrees, the hypotenuse and the opposite side are actually the same length. So we end up with 1. So the sine has to be between negative 1 and 1. What about the cosine? It's the same, we're in the same realm because O over H and A over H act exactly the same way. Okay. What about tangent? Tangent is O divided by A. Can O be bigger than A in a right triangle? Yes. Can they be the same size? Yes. Can A be bigger than O? Yes. Can they be negative? Yeah, in quadrants 2 and 3 and 4 they would be. So tangent has no restrictions. In fact, tangent can even equal negative infinity and infinity. Okay? So we have no restrictions on tangent. What about the cosecant? Which we calculate doing H over O. What are the bounds on the cosecant? Right, so can the cosecant be 1.45 over 1? Yes. Can it be the opposite? 1 divided by 1.45? No. So the cosecant is the exact opposite of the sine, which means everything but this. The cosecant has to be bigger than 1. It actually can equal 1. So 1 or bigger, what else? What else has to happen? Cosecant has to be 1 or bigger, or it can be 2 or 3 or 4, yeah, any of those. But what about the negative side? It can be negative, but not every negative number. Well, h has to be bigger than O. So it has to be -1 or smaller. So the cosecant is anywhere from -infinity to -1, union with 1 to infinity. What about the secant? It's the exact same. And what about the cotangent? Cotangent compares A and O, and there are no restrictions. It's an unlimited domain. Okay, so sine and cosine have to be between -1 and 1. And then cosecant and secant have to be everything but those numbers from -1 to 1. So you're just going to say yes or no, depending on what the ratio is. Okay. The next one, evaluate the following expressions exactly. So we just use the unit circle. So if I wanted the cosine of 120, I grab my unit circle and I look at 120. And do I look at the x value or the y value? The x value, 120, the x value is -1/2. Easy enough. Same thing in radians. So the next one says, why don't you guys come grab your unit circles? This next section might look a little tough, but it's actually pretty easy. It says, find all possible values of theta between 0 and 360 degrees for which the following problem is true. So I'm just making one up. This is not in your book. But what angles in one positive rotation of the unit circle spit out cosine values of -√3/2? So look at your unit circle. Cosine is x or y? X. So which angles create an x value of -√3/2? 150 and 210. Everybody see that? Okay. What about the sine of theta equals √2/2? That's a 2 over 2. 45 and, nope, oh, sorry. I'm looking in the wrong place. Yes. 45 and 135. Does everybody understand that? Okay. What about when is the sine of theta equal to 0? So when is the y value equal to 0? 0 and 180. Okay. All right. And then the last set, find the smallest possible measure of theta if the indicated information is true. So what if I know that the sine of theta is 0.83 and I know I'm in quadrant 2? What is the smallest angle that fits that? Well, first I need to find the reference angle. So I know I'm in quadrant 3. So here is theta. This is my reference angle. To find the reference angle, I just invert the sign. So inverse sine of 0.83 gives me a reference angle. I must be in radians. Hang on. Yeah. So I get 56 degrees. So how big is theta? I just do 180 minus the answer. 123.3. Okay, let me do that again. What if the tangent of theta equals -5 and I am in quadrant 4? So I draw my angle in quadrant 4. This is theta. Here's my reference angle. So I invert the tangent of 5, and I get 78.69. Oh, sorry. Yeah. You do have to do the negative. So I get 78.69 degrees. But it's in quadrant 4. Well, it should have been positive. Sorry, whatever. So how do I find theta? 360 minus 78. Okay. All right. What if the secant of theta is equal to negative 1.0285, and I am in quadrant 3. So I draw my angle in quadrant 3. That's theta. The reference angle is right there. So I'm going to do secant cosine of what? Negative 1.0285. And when I hit enter, I get error. No. What did I do wrong? Can I take the inverse cosine of 1.0285? It's bigger than 1. So what I want to do is take the inverse secant. But I don't have an inverse secant button, so I'm going to do this. 1 divided by negative 1.0285. Right? If the secant is negative 1.0285, then the cosine is 1 divided by negative 1.0285. Okay, and I get 166 degrees. Well, that doesn't make any sense. Oh. No, anyway. So you would do 180. I ended up in the wrong quadrant. That's what happens when you just make these up. But let's say it was 50 degrees. I would take 180 and add 50, and that would give me my angle. Yes, because 180 will get you there, and then the reference angle will get you to there. But it didn't work out because I actually created an angle in the wrong quadrant. So no, it depends on where you are. You could do 180 plus or 180 minus or 360. It just depends on where you land. Okay, get to work.